Hello everyone and welcome back to the Proactive Learning YouTube channel. Today we're going to go through question 14 from the Edexcel A-Level Maths 2020 Paper 2 past paper. So let's see what the question is about. So we're told a circle C with a radius R lies only in the first quadrant. So that's the first detail the examiner's given us. And we've also been told that the circle touches the x-axis and touches the y-axis. So straight away, we can almost get an image of what this circle is going to look like. So if we have our y-axis and our x-axis, we first need to understand what is meant by the first quadrant. So when it comes to what it means, the first quadrant is where our x and our y value is positive. Our second quadrant is when our x value is negative, but our y value is positive. And then we have our third and fourth quadrant as well. Now, since our circle lies only in the first quadrant, what that basically tells us is we only need to have a look at this yellow area here. So we can almost ignore the second, third, and fourth quadrant for the time being, or for this question. Now, the second detail says the circle touches the x-axis and touches the y-axis. So what does that mean? So that means that our circle can't be somewhere like here, can it? Because it's not touching the y-axis. On the other hand, it also can't be somewhere here, can it? Because it's not touching the x-axis. So there's only one possible place this circle can be. It needs to be somewhere here where the circle is touching both the x and y-axis without crossing into the other quadrants. But the other thing that you might realize is there a way we can sort of figure out or state the center of this circle? So the general form of a circle that we know is x squared plus y squared is equal to r squared, where the center of this circle is 0, 0, the origin. But we know that the center of our circle isn't going to be the origin for this particular example. So what is our center? Now, something we need to realize is since our circle touches the x and y axis, in other words, this length here is the radius, and this length here is also the radius. So if we think about what the center is as a coordinate, the coordinate of the center is just the radius for the x direction and another positive radius for the y direction. So that is our center. But how do we show that in our equation? So whenever it comes to centers of circles when it isn't the origin, the general form is something as follows. X minus a all squared plus y minus b all squared is equal to r squared, where a, b is the center. But now here, our a is going to be r and our b is going to be r. So let's substitute those in. So x minus r squared plus y minus r all squared is equal to r squared. That's the equation of our circle. But let's see what the question is actually asking us to find. So the line L has an equation 2x plus y is equal to 12. Show that the x coordinates of the points of intersection of L and C satisfy the following expression. So whenever it comes to finding points of intersection, we want to substitute one expression into another, right? So we've already found one of our expressions, which is the equation of our circle, but now we also have this expression for our line L, which is 2x plus y is equal to 12. Now, when looking at our answer, we have x terms in it, we have the variable r, so our radius, but we don't have any y terms in it, do we? So in other words, what the examiner is basically hinting at is we need to substitute an expression for this y, because we don't want a y for our final answer. Now, the good thing here is we've got exactly what we need with this equation of the line. Now, what is y equal to? Y is equal to minus 2x plus 12 if you do some rearranging. Now, we can substitute that exact expression into the equation of our circle. So let's do that. So we have x minus r squared plus, now instead of y, we'll write minus 2x plus 12, take away r, all squared, is equal to r squared. Now, here we have two sets of double brackets that we can expand out. Before we do that, we need to just be very careful with this double bracket here. You could also write this as minus 2x plus, in brackets, 12 minus r. Now something to remember here is 12 minus r, it's a constant because our radius can't change, can it? So you can consider the constant as 12 minus r. So let's expand out the first set of brackets. So x minus r all squared is the same as saying x squared minus 2r lots of x plus r squared. Then we're going to add 4x squared minus 4 lots of 12 minus rx. Then we're going to add 12 minus r all squared, and that is equal to r squared. So we've got a couple brackets that we still need to expand out. But before we do that, we can already simplify a little bit. So we've got x squared here, and we've got a plus 4x squared here. So we can just combine those really quickly. So we have 5x squared. Then we have minus 2rx plus r squared. Now here we have minus 4x multiplied by 12, and we also have a minus 4x multiplied by minus r. In other words, we've got a plus 4rx. Then here, 12 minus r all squared, we can write that as 144 minus 24r plus r squared is equal to r squared. Now here, we can simplify. Take an r squared away from both sides, and then we're left with 5x squared minus 2rx plus r squared. Now here, minus 4 times 12 is minus 48. X plus 4rx plus 144 minus 24r, and that is equal to 0. So from here, we have our 5x squared. But now let's have a look at our x terms. We've got a minus 2r lot of x. We have a 4r lot of x. And that's pretty much it. Apologies, we also have a minus 48x. So in other words, we've got minus 2r lots of x plus 4r lots of x, and then we have to take away 48 lots of x. So that's simply the same as just saying 2r minus 48 lots of x. From here, we have our constants now. So we have a r squared. We have a plus 144, and we have a minus 24r. So what we're left with as our constant is the following. So we have r squared minus 24r plus 144, and that is equal to 0 now. So let's see if that matches up with what the questions asked us. And that has. So that's part A all done. But let's have a look at part B now. So part B says, given that L is a tangent to the circle C, find 2 possible values for R, giving your answer as fully simplified surds. So quite a lot to unpack here. So whenever we have some line and some circle, where the line is a tangent, how many times does that line cross the circle? Now, one thing that we know about circles is a tangent only crosses at a single point. So in other words, there's only a single point of intersection. But on the other hand, we've been told to find 2 possible values for R where they need to be fully simplified surds. Now for me, the term fully simplified surds tells us we're not going to get a very clean, nice answer, are we? So in other words, this is almost like a hint that we might need to use the quadratic formula at some point. But the key thing here is whenever it comes to part B, part A of the question always helps us to find the answer. So why did it help to find this expression here? And the main reason why is because we have a quadratic, don't we, for part A, for our intersection points. So in other words, can we find the number of solutions that this quadratic has? Now, we could. Now, what is one thing that we can find out when it comes to quadratics and the number of solutions they have? The discriminant. So, one thing that we need to remember is for part B, whenever it comes to a tangent, our discriminant b squared minus 4ac, it needs to equal 0. But let's see what this looks like. So b is 2r minus 48, so we have 2r minus 48 all squared. Take away 4 lots of, in this case, a is 5. And c is r squared minus 24r plus 144. And that is equal to 0. So here, let's expand out these brackets. So we have 4r squared minus, in this case, we have 96r, take away another 96r, plus 48 squared. Then we have minus 20 lots of r squared minus 24r plus 144, and that is equal to 0. Now, since this is a calculator paper, feel free to just put the larger calculations in your calculator. So we have 4r squared minus, now 96 times 2, that's simply minus 192 lots of r. 48 multiplied by 48 is positive 2,304. Then we have minus 20 lots of r squared. Then we have 20 times by 24, which is positive 480r, because we have a negative multiplied by a negative. And then we have 20 multiplied by 144, which gives us negative 2,880, and that is equal to 0. So from here, we have a 4r squared term, we have a minus 20r squared term. So if we combine those together, what do we get? We get minus 16r squared. Now let's have a look at our r terms. So for our r terms, we have a minus 192r, and we have a positive 480r. So minus 192 plus 480, what do we get? We get positive 288r. And last but not least, we have a positive 2,304 and a negative 2,880. So 2304 minus 2880, what does that give us? We get negative 576, which is then equal to 0. So now we have a quadratic in terms of r only. So let's try and solve this. So one thing we can realize is all of our coefficients are even. So let's just divide everything by 2. So we get minus 8r squared. Then we have plus 144r, take away. And then in this case, we have minus 288, that is equal to 0. All of our coefficients are still even, so let's half that again. So we have minus 4r squared plus 72r, take away 144, equal to 0. Everything's still even, so let's do it again. So we have minus 2r squared plus 36r, take away 72 is equal to 0. Once again, everything is still even, so let's do that again. So in this case, instead of dividing by 2, let's divide by negative 2. So then we get r squared minus 18r plus, and then in this case, minus 72 divided by minus 2 is the same as positive 36, and that's equal to 0. So now we have a quadratic. Now we could factorize this, but remember earlier in the question, we were asked to find the answer or the possible values for r as fully simplified surds. So let's just go ahead and use the quadratic formula straight away. So we have minus b plus or minus square root of b squared minus 4ac over 2a. So what is b in this case? b is minus 18 plus or minus, then we have the square root of, what is b squared? B squared is 18 times 18, which is 324, take away. Now 4 times 1 times 36 is equal to 144, and all of that is over 2. So if we simplify that down, 324 minus 144, that gives us 180. So we have 18 plus or minus the square root of 180 over 2. Now, a nice and easy trick we can use, just put root of 180 into our calculator. We get 6 root 5. So this is the same as 18 plus or minus 6 root 5 over 2. Now here we can simplify this one more time. 18 and 6 are even, so 18 divided by 2 is 9, plus or minus 6 root 5 divided by 2 is 3 root 5. So what are the two possible values for r as fully simplified surds? It is 9 plus 3 root 5 as r, or r is equal to 9 minus 3 root 5. And that would be our final answer for part B. So hopefully that answered some questions you guys had. Quite a tricky question in terms of algebra. Very easy to make simple mistakes on these questions because you're just dealing with so many variables, so many numbers, and so many brackets. With that, please like, comment, subscribe, and also feel free to let me know in the comments below if there are any other past paper questions that you specifically want me to show the solution to. I'm happy to do so. And with that, that'll be it for today's video. See you.